All right, cadets, we're going to finish up with this lab by doing the graph. So today our objective is to graph the information that we have in our data table. So here you can see I didn't complete the data table because I certainly want you to have your own work. But what I did lay out here is to show you the extremes, right? The beginning, our values at the beginning, and I got it 70 degrees for mystery material A that it refracted at 22 degrees. Taking the sign of those, we would get 0.94 and 0.37. So what we are going to graph is all of this information right here, right? So as you can see, the decimals are a little bit more challenging. So number one is we have to figure out exactly how do we want to graph this material? How should we scale the axes and so on? So I had asked you guys to print off printable graph paper. So hopefully you found something like this that we have used in the class before. If you don't have graph paper, then just use a ruler and draw yourself nice straight lines and so on. So remember when you graph, right, we're going to begin by coming in, right? We did our axes a little bit differently here. Let's see, I'll go ahead and go with that. So if you come up one block, we're going to use a ruler. I'm freehanding this right now, but I want you to certainly want the job, right? So remember we came in, gave ourselves a boundary. Make sure you give yourself a title. So this is finding the index of refraction. Could be the title of your graph. You can say for mystery material, right? So we're going to use mystery A is our material. Right? All right, on the x-axis, you're going to have the sine of theta 2. And on the y-axis, you're going to have sine theta 1. Right? So the number one challenge is coming up with the scale. Right? So on the sine of theta 1, we go from 0.17 to 0.94. So we're going to need that to go all the way. Remember the rule. Take this value and round it up to the highest number that's easy to divide. So here we could round 0.94 to 1. 0.37, I think I'm going to round that to 0.5. And you'll do the same thing down here. So if we go back to our graph paper, remember, you don't want just a little graph that takes up the square in the bottom. We want this to be spread out. So I'm going to make one up here, which means halfway between is 0.5. Half of that is 0.25, right? So then halfway here is going to be 0.75, which means each one of these lines is worth 0.05. So remember there's 5 blocks in there. So if I take 0.25 and divide it by divide it by 5, I get 0.05. For this axis, if I want to go up to 5, right, and we have to go to 0.5. So I could go 0.1, 0.2, 0.3, 0.4, 0.5. That might work. That could be easy. 0.1, 0.2, 0.3, 0.4, 0.5. That might be an easy thing to do. That's going to get me that my last point is going to be somewhere up in here, which spreads that out quite a bit. If I divide this by 5, 0.1 by 5, each one of these is worth 0.02. So that means this is 0.12, 0.14, 0.16, 0.18, 0.2, 0.22, 0.24, 0.26, 0.28, and so on. So it allows me to really predict where these numbers are going to go on our axes. Right, so if we look at our first numbers, sine of theta 1 is 0.17 and 0.08. 0.17, so 0.17, this would be 0.05, 0.1, 0.15, right? And this would be 0.2, so it's going to be right in here somewhere, and 0.08, 2468. So we're going to be about right there for our first data point. Our second data point, 0.34 and 0.16, 0.34 and 0.16. So this will be 0.3, 0.35, So 0.34 is going to be here, and 0.1, 0.12, 0.14, 0.16. It'll be right in there. My very last point, now you should have all the points in between. You'll be graded on plotting those correctly. Here I have 0.94 and 0.37. So 0.94, this would be, right, 0.8, 0.85, 0.9, 0.95. 0.94 is going to be slightly below that. And 0.3 here, 246, 0.37 is going to be in here, right? So we should have this last line being about right there. And of course, 0, 0 is a valid point. You, of course, are going to have some more points that are going to fall into this area here, right? So if I circle that, you better fill that in with all your extra data that you have, or all the other data that you have, right? So I'm just going to keep you from doing your own work, or have you do your own work, rather. I apologize. So that's why I don't have that full data table filled out. And then what you do, right? We take a ruler, and remember, we try to line up to draw a straight line. So this, from what I'm seeing, I'm predicting that we're going to get a straight line here. So you take a ruler, and remember, you draw the line of best fit. So if I take a straight edge and I try to connect those points, right? I'm going to line up my ruler, and remember, you don't have to go through every point, but you go through as many points as you can, having as many points above the line as you do below the line, right? Okay, so you're going to do that for both mystery A and mystery B. Your final step is then to calculate the slope of the line. So we want to be able to find the slope. So I'm going to write it here, which I'm fine with you doing that. Remember, in math class, it's y2 minus y1 all over x2 minus x1. So remember, we ignore our data points and we pick 2 points from this line that are going to be easy to predict their values. And I'm looking for 2 points that cross right at the corner of one of our squares here. So I think the best point, looking at my data, looks to be almost right up in here, maybe. I can pick this point right there. And then I'm going to pick, there was one down here that looked pretty close to going through. I'd say right here, right? So there's my 2 points. And here's my 2 points. So remember, you are to use rulers, right? All right, so my y2 is this value. And this value is my y1. This is going to be my x2, and this is my x1. So y2 is going to be 0.95 minus, and you might come up with a different answer. So don't think you're going to get the same answer as me, depending on the data points that you place in this area right here. So that's what I did with those 3 points, but you're going to have 7 points that you're going to line up. So 0.95 minus 0.1 all over, remember each of these are 0.02, so that's 0.04 minus 0.4. I'm sorry, 0.4 minus 0.04. So it's x2 minus x1. So it's 0.4 minus 0.04. So that's going to give us 0.85 divided by 0.36. Right? So plug that into your calculator and you get a number, and that is N. So your N value for mystery A material is equal to the slope. And remember, the N is the index of refraction. So whatever number you get for that slope is equal to your index of refraction. So I want you to repeat the same process for mystery material B. And at the end of class, hopefully you're done with that. You're going to turn in your data table and both graphs. Now you might have enough room right, to fit 2 graphs on one piece of graph paper. So I'm fine with that. If you want to put one graph up here and another one down at the bottom, that can work. Or you can turn it sideways, right, and put one graph on this side of your paper and the other graph over here. That might even be a better option to make use of your graph paper to fit one on one sheet of paper, two on one sheet of paper. Hopefully that all works. Of course, you can chime in, unmute yourself, and let me know if you have any questions. So good luck. I hope that all makes sense.